You know, every single time you stream a video, fire off a text, or even just browse the web on your phone, you're plugging into this gigantic invisible network. And chances are, the tech that's making it all happen, the real core of your device, is powered by Qualcomm. So today we're going to peel back the layers and see exactly how these wireless systems that connect our entire world are actually built.
It's a question we almost never think about, right? But it's pretty wild when you do. How does your voice, or a video, or just a simple web page, how does that digital stuff leave your phone, fly through the air, and get where it's going in literally milliseconds? Well, it's not magic, that's for sure. It is an absolute masterpiece of engineering.
And here's the secret. It's not about one single magical chip that does everything. No, the real magic is in a complete end-to-end system where every single piece is meticulously designed to work in perfect harmony with all the others. You can kind of think of it like a high-speed relay race for your data, where every single handoff has to be absolutely flawless.
All right, so to really get how this works, we're going to follow a signal on its journey. We'll start with the digital brain, which is the modem. Then we'll get to its analog voice, the RF front end. We'll see how it all gets broadcasted. We'll uncover the secret sauce of system integration, talk about the tough engineering hurdles, and finally, see where this whole system actually lives out in the real world. So our journey kicks off right here, with the part of the system that does all the heavy lifting, all the thinking, the modem. This is basically the starting line for any piece of data that wants to go wireless.
So what exactly is a modem? Well, you might also hear it called a baseband processor. Its job is to be the ultimate digital traffic cop. It takes all your data, just ones and zeros at this point, and preps it for the journey, making sure it follows all the super complex rules and protocols that the cellular network demands.
Now, this is where it gets really cool. The modem performs something called modulation, which is like translating those digital bits into a language that can be carried on a radio wave. Super important. It also does channel coding, which adds little bits of redundant information to protect the signal from errors. Think of it like a spell checker for your data stream. And it handles incredibly complex signal detection, which is kind of like trying to pick out a single friend's voice in the middle of a loud concert. It's the brain of the whole operation, no doubt.
Okay, so the data's been processed by the digital brain. It's all ready to go. But how does it actually speak to the world? Well, that's where our next piece of the puzzle comes in. We're talking about the RF front end, or RFFE. This is the device's analog voice.
The RFFE is the critical bridge between the digital world of the modem and the analog world of radio waves. It takes those precise digital instructions and turns them into actual radio frequency signals that can be broadcast through the air. And, just as important, when a signal comes in, it does the exact reverse, turning those waves back into digital bits the modem can understand.
And the RFFE isn't just one thing. It's more like a highly specialized team. You've got power amplifiers that give this signal the big push it needs to travel a long way. You have filters that clean everything up, making sure only the exact right frequencies get through. Switches are like traffic directors, and then low-noise amplifiers are amazing at catching really faint incoming signals without drowning them out with static. So the signal is generated, it's cleaned up, it's amplified, it's ready to go. Time to send it out. But the air isn't just some big empty space. It's more like a complex highway system with tons of different lanes, or frequencies, and your device needs to navigate it perfectly.
This is a huge deal for 5G because it uses different kinds of spectrum. Think of sub-6 GHz as your main highway. It's the workhorse providing really wide, reliable coverage over huge areas. Then you've got M-Wave. That's like a Formula One racetrack. It delivers absolutely mind-blowing speeds, but for shorter distances. A truly great system needs to be a master of both. So how does the system actually use these airwaves so well? Through advanced antennas. And these are not your grandpa's rabbit ears. Modern systems use a bunch of antennas and a brilliant technique called beam forming. It's like using a laser pointer to focus the signal directly at the cell tower or your device. This is absolutely critical for those super fast wave signals, which can be blocked by anything from a wall to just your hand. By focusing that beam, the system makes sure you get a strong, reliable connection, which means better quality and coverage for everyone.
Okay, so we have a smart brain in the modem and a powerful voice in the RF front end. But the real game changer, Qualcomm's true secret sauce, isn't just in making great individual parts. It's about making all those parts work together as one single, flawless system.
And this is the key. You have the digital brain, the analog voice, and the antennas. When they are all designed from day one to speak the same language, to work together, you get something really special.
The system can make tiny adjustments in real time, optimizing for power and performance in a way that a bunch of mismatched, separate components never ever could. And for you, that means faster speeds, way better battery life, and a connection you can actually count on. Now, making all of this work inside a tiny device that you can slip into your pocket, well, that is an unbelievable engineering challenge. So let's look at some of the major hurdles that these integrated systems have to leap over every single second you're using them. Just think about it for a second. Your phone has to shout to be heard above the noise of thousands of other signals, all while sipping power as slowly as possible to make your battery last. It's this constant tug of war. It has to manage all the heat it generates in a tiny, sealed box, a thermal problem that just gets harder and harder as tech gets more powerful. And it has to seamlessly jump between dozens of different frequency bands as you walk down the street or drive across town, all without you ever noticing a dropped call. Solving these problems is what separates a good wireless system from a truly great one. So now that we've followed that signal all the way from a digital thought to a radio wave in the air, let's zoom out. Let's see where these complete end-to-end systems actually live and work in our world today. And yeah, while your smartphone is the most obvious place to find this tech, it is truly popping up everywhere. It's in smart IoT devices all over your home. It's in the incredibly complex communication systems in our cars, and it's even in the network infrastructure, the cell towers and base stations that powers the whole thing. This integrated approach is connecting pretty much every part of modern life.
So, if there's one single thing you take away from all this, let it be this. Modern wireless, and especially 5G, isn't just about a faster chip or a fancier antenna. It is all about the deep integration of the modem, the RF system, and all the signal processing working as a single, highly optimized unit. That's the blueprint. And that brings us to one last question. We always want more power, faster speeds, in smaller devices with batteries that last forever. As we keep pushing the boundaries of what's possible, what do you think is the next massive engineering hurdle for wireless tech? Is it better power efficiency, managing heat, or is it something else entirely we haven't even thought of? It's a challenge that engineers are trying to solve as we speak.